Good evening, everyone. We are tasked to discuss about time to travel groundwater in confined aquifers. In this topic, we will discuss the overview or the methods that can be used and the formulas in this topic. Also, we will define groundwater in confined aquifers. So, first, a brief explanation about the methods that we use. So, the first method is the Thames method. So the equations known today as the steady state Thiem Dupit for Khmer or Thiem for Schmier equations can be used to determine the coefficient of permeability of an aquafish from measurement made during a pumping test using a fully penetrating well with a 100% open hole and two or more observations well. Next is the Thies method. So Thies method was the first to develop a formula for unsteady state flow that introduces the time factor and the storativity. He noted that when a well penetrating and extensive confined aquifer is pumped at a constant rate, the influence of discharge extends outward with time. So last is the Jacobs method. In pumping tests with multiple observation wells, the closer wells will meet the condition before the more distant ones. So time is plotted along the logarithmic x-axis and drawdown is plotted along the linear y-axis. Next, so confined aquifers. Aquifer unit bounded above and below by low permeability confining units. So when we say the confined aquifers are bounded above and below by permeability confining units, it means that the aquifer, which is layer of permeability rock and sediment that can transmit and store groundwater, is surrounded by layers of rock or sediment that have low permeability. So permeability prefers stability of material to allow the flow of fluid through it. Low permeability confining units, also known as confining layers or aquatards. It has low permeability and restrict the movement of the water. So these confining units act as barriers above and below the aquifer, preventing the water from easily flowing in or out. Next, water is generally pressurized, causing well water's levels to often rise above the upper confining units. So when water is pressurized in a confined aquifer, it means that the water within the aquifer is under sufficient pressure to cause water level in wells drilled into the aquifer to rise above the confining unit. So this phenomenon is also known as the artesian conditions. In a confined aquifer, the water is trapped between layers of low permeability materials such as clay or shale, which acts as confining units. These confining units prevent the water from easily flowing in or out of the aquifer vertically. So as a result, the water becomes confined and can build up pressure within the aquifer. Next, investigate piezometric surface as opposed to the water table for unconfined aquifers. So the piezometric surface in unconfined aquifers represents the level to which water will rise in wells due to hydrostatic pressure, while the water table indicates the upper boundary of the saturated zone where the groundwater pressure is atmospheric. So the piezometric surface is above the water table due to increased pressure from groundwater flow. It is a theoretical surface that can fluctuate based on recharge and discharge. By monitoring the piezometric surface, we can understand groundwater movement and assess the health of unconfined aquifers. Next, confined aquifers. So we have four considerations in a important quantities. So first, distance from well to piezometric, drawdown in piezometer, depth of aquifer, and discharge from pumping well. Next, in assumptions, we have 10 things to consider. So first, aquifer is confined. So it means a confined aquifer is surrounded by impermeable layers, restricted water flow. So the pressure within the aquifer can cause water to rise above the upper confining layer, creating artesian conditions. So it can store groundwater and protects it from contamination. Next is the infinite areal extent. So when referring to an aquifer with an infinite areal extent, it means that the aquifer is not limited in size and extend indefinitely. So implies that the aquifer covers a vast area, potentially spanning with a great distance without any physical boundaries or constraints on its lateral extent. Next, homogeneous isotropic constant thickness. So a homogeneous isotropic and constant thickness aquifer means that it has consistent properties throughout, such as uniform permeability and porosity. It behaves similarly in all directions and maintain a uniform thickness. So these characteristics simplify groundwater flow and analysis of modeling. Next, piezometric surface is horizontal prior to pumping. So when a well is not pumping in an unconfined aquifer, the piezometric surface, which represents the water level, is typically horizontal. So this indicates that the water table is at equilibrium with the pressure and hydraulic gradient evenly distributed. It results in a flat or nearly flat water surface. So next, aquifer pumped at constant rate. A fully penetrating well is drilled throughout the entire thickness of an aquifers, allowing it to access water from the entire saturated zone. The well is screened over its entire length, allowed water to enter the well bore from all levels of the aquifer, and maximizing water extraction potentials. Next, well is fully penetrating and screened over entire thickness of aquifer. So when water is removed from the storage, such as well in an aquifer, is discharged instantaneously. As the water is extracted, the hydraulic head, which represents the water level of pressure decline, this decline occurs quickly and is directly related to the amount of water removed from the storage. So next, last, well diameter is small or unsteady state. So a small well diameter refers to a narrow opening or borehole used for extracting groundwater. A smaller diameter limits the volume of water that can be pumped from the well at given time, potentially affecting the rate of water extraction on the overall yield of the well. So those are the assumptions in confined aquifer. Next, note, in a confined aquifer, water must come from storage. So in theory, this means uh, must all in theory this means must always have unsteady state flow, and in practice, if change of S is small, can treat conditions as steady state.